I'm so proud of myself.
Okay, we're recording. Today is the 5th of November. We're doing section 5.3, talking about properties of parallel lines or more theorems that deal with parallel lines.
This is another theorem.
This is a theorem that says if two lines are parallel, the black lines would be our parallel lines. Line L and line M. Then all points on one of those lines, so point A, B, C, and any other points, are equidistant from the other line. Now remember, when we said we're talking about distance, we're talking about the perpendicular distance between two things. So if you are given the fact that you have parallel lines and there are 3 points with lines drawn to the bottom, and they are perpendicular, that means that's the perpendicular distance. And I said name 3 congruent. Wait, I need to put some more letters up here. How could we use this information? Name 3 congruent segments.
AE, CF, CG.
AE is congruent to BF, is congruent to CG. That's how we can use that information. Okay? Which basically it's saying the parallel lines, it's the same distance between them all the way across. Which obviously, because they're parallel. Alright, so it's just a fancy way of saying it. Okay? Another theorem about parallel lines is that if 3 parallel lines, we'll call this line L, line M, and line N.
That was really creepy.
And they are all parallel to each other. If 3 parallel lines cut off congruent segments on one transversal, here's transversal T. Where it passes through those 3 lines, notice that there are 2 equal segments formed. Then they cut off congruent segments on every transversal that passes through them. We'll call this transversal S, and we'll call this transversal R. Now, how is this information useful to us? What can we do with it? If that's yes. Okay, well, we're going to talk about it. If this is the information that's given, this is basically what we know. If these 3 lines are parallel, and one of the transversals is marked with equal segments, like here and here, then every line that we draw through there will have equal segments. So I could ask you, please name the midpoint of segment AE. It's point C. It has to be. Which means, what is a segment congruent to AC? No. through the same line, it creates equal segments on
CE.
this line. CE is congruent to AC. Oops. Too many slashes. I could also say D is the midpoint of what line segment?
BF.
BF. So name a line segment congruent to DF.
BB.
BD. Okay? So that's what this information tells us. So we can help to identify congruent segments. That's what it's for. But the three lines have to be parallel. And the line coming through has to be separate. One of them, if it shows as equal, then they're all equal. All right? Now, this theorem leads us into our next theorem, which deals with triangles. All right? And I'm going to show you real quickly how this works. I have three parallel lines, right? Suppose I took transversal R and scooted it over until it was intersecting here with transversal T. Is that still a transversal cutting through three parallel lines where there were two equal segments formed here?
Yeah.
So what does that mean about these two segments?
That's still
They're still congruent, all right? Which leads us to our next theorem. It says a line that contains the midpoint of one side of a triangle is two things. First, it is parallel to another side, and it also passes through the midpoint of the third side. Now the dotted line at the top would be our third parallel line. Well, we probably wouldn't have that drawn in a triangle, okay? Because it's understood that those two lines are crisscrossing through a parallel line. But if the left side of that triangle is separated into two equal pieces, then the right side also has to be separated into two equal pieces, according to the theorem we just learned on the last slide. So what can we do with this information? For one, we can figure out side lengths, or which sides or whatever are congruent to each other, okay? Because if it's passing through the midpoint here and it's parallel here, then it is also passing through the midpoint here. All right? If it passes through both midpoints and you don't know this, if this isn't given, well, this helps us to see that if it's going through both midpoints, then it is what?
parallel.
Parallel to this other side. Which, how does that help me?
Improving parallel.
How about angle measures?
Correspond.
Corresponding angles are congruent, aren't they? So let's say I knew this angle measure right here.
It's 40.
Let's say it's 40. And I'm asked to find this.
No, it's 100.
It's 140. Because the corresponding angle is 40, and this is a supplement to it, because they form a straight line. We also know, so kind